Hey, it's Ross from RossLukeman.com. Today, I'd like to talk to you about the top 10 safety mistakes that I've seen when it comes to mobile power systems. And these can cause fires, electrocution, as well as mysterious shutdowns, which happen more often than we would think. And I have kind of a cheat sheet here. These are mistakes that I've made, and they're mistakes that my customers and students have made. And I'm going to tell some of the stories. Now, the first one is a big one. It's loose connections. And there's kind of 4 ways that this can happen. I've got a list here. So first one is bolts left untightened. So as you can see, we have a lot of bolts here. And if you assemble one of these systems and do not go back and check each bolt, you may just leave one untightened. Any loose connection can get hot due to a reduced surface area between the conductors. And in general, it can also cause mysterious shutdowns. Loose connections are notorious for shutting down your system, and you don't know where the shutdown is occurring. You just know something is flickering and turning on and off. I'll talk about that more in just a second. The next one is bolts that are not properly torqued. So with this power system here, it's sitting still, but once we put it in a boat or a vehicle, it's going to be bouncing around and things can shake loose. So you want to make sure that you properly torque all of the bolts in your system. Go ahead and get a torque wrench. And this is kind of a Goldilocks situation, because if it's too loose, when you tighten it, it could shake loose over time, get hot, and cause a fire or other problems. If it's too tight, you can snap the bolt, because we have a lot of brass and copper and a lot of softer metals in these electrical systems. And if you overdo it, it can also be bad and damage the equipment or cause you to have to replace the equipment. So you want to get a torque wrench and make sure you torque down these bolts to the proper specification. And that goes along with my first point, to just make sure that you torque down every bolt. So as you can see, these are kind of basic. We'll get into some more complex ones later on, but these are really basic things that are easy to do, but they do get overlooked. So moving on. The other one is no locking hardware. This is point number 3 of loose connections. So with mobile power systems, they're mobile, they're bouncing around. If you don't have a lock washer on every single bolt, it will eventually shake loose. You can also use a knurled flange nut like they have on this Blue Sea bus bar here. But basically have some kind of locking hardware, ideally not a nylon locking nut, because the nylon can heat up and it can weaken over time. So I would use a stainless steel lock washer for all of your connections. And oftentimes that's going to come with the hardware that you buy, such as this Lynx distributor from Victron. It's going to have all those lock washers in there, but just make sure that you have those in each connection. I have flown from Houston to Atlanta to fix a system that was missing one lock washer. And it basically, on the negative cable leaving the battery bank underneath the vehicle, there was one lock washer missing. Everything else had a lock washer. That one connection got loose, and the entire power system inside this Sprinter van would shut down intermittently. And of course, nobody knew which connection in the entire system was causing the problem. The way that I found it was I touched the DC connections. For low voltage, it's okay to use your hands, and you can also use a thermometer or an infrared thermometer to get the temperature. And if you find a hot spot that's hotter than the adjacent areas, that's a clue that you have a loose connection. And that's how I found it. The connector wire that was on that connection was also melted, so that's another giveaway. So loose connections will get extra hot and start to melt things around them. The next one is bad crimps. I use a hydraulic crimper from Timco to make my cable crimps to add the lug terminals onto the end. And if you are using a cheaper crimper that's too loose, that connection can be loose and it can get hot over time. If the strands of the cable are not properly crimped into that lug terminal, it can cause problems over time. So you want to make sure that you use a hydraulic crimper, or if you use a hammer crimper, make sure that you get a good solid crimp. And a good test for that is just to take the cable and hook a screwdriver through the lug terminal and give it the pull test and make sure it doesn't pull out of that connection. If it does, it's too loose. So moving on, did want to mention another intermittent shutdown. So I had a call a couple of days ago and everything was working in their system, but their solar power would stop working occasionally. And what it was the incoming solar voltage would go from about 30 volts down to 13 volts. And they didn't know what was causing that. And they thought there might be an issue with the solar charge controller. And it was just cutting off because once you go below a certain threshold, it doesn't have enough voltage to charge the battery. So the controller would shut off. And what it was a loose connection. It was the cables coming in off the roof to the solar breakers. And there was just a loose screw on the wire coming in, the positive solar wire coming in off the roof. It was loose right at that breaker, and it caused problems for the entire solar circuit. And nobody knew where. We tried to isolate the issue, but it was just one loose screw. So that's another anecdote and a reason to make sure that you get all of your connections tight and to the proper torque specification as well. Now, if you're interested in your overall power system, not just the safety hazards that you might run into, then I have a resource that you may be interested in called the Ultimate Van Power Cheat Sheet. It's got a discussion of solar power, shore power, and alternator power down there on the end. It's going to talk about how all together they're going to make a holistic power strategy, and they're really going to cover you no matter where you go out on the road, whether it's day or night, sunshine or rain, you're going to be covered, and you're going to make sure that you're not going to be worried about running out of power. There's also a discussion about different battery types and the strengths and weaknesses of those. That's going to help you narrow in on which battery type is going to be right for you. And then lastly, there is an entire system diagram that's going to show your system conceptually all the way from your charging sources at the top through the system, and it's going to show how that power comes out and powers things like your microwave or your laptop. For instance, how does the solar power come in, run through the system, and come out and charge your laptop? So that's a really illuminating diagram that is included with the Ultimate Van Power Cheat Sheet. To grab your own copy, all you have to do is click that link below or go to rosslupin.com/vanpower. All right, so moving on to the second one, and you may laugh at me here, but I've seen people leave this out. They don't have a battery cutoff switch. So the safety implications of the battery cutoff switch, number one, it's going to allow you to do maintenance and prevent the battery power from electrifying all these cables out in the system so you can add or subtract components. But more importantly, it's also going to allow you to shut the battery power off in the event of a fire. So if you can't prevent the batteries from sending their power out into the system, if a fire develops, you're just going to have to let it burn. And so you definitely want a battery cutoff switch here. And as I said, I had a consulting call the other day. The guy had purchased an existing system from someone else who didn't know what they were doing. There was no battery cutoff switch. So I thought I would mention it here. Number three is going to be, this is the third big category. We had a bunch of them for loose connections. So that's a really important one. That was number one, loose connections. Number two, no battery switch. Number three is the fuse rating is not related to the cable capacity. So all of these cables have an ampacity, we can call it, an amperage capacity, or a max amperage, a max current that they can have flow through them. And that's based on the cross section of copper that you have and the temperature rating of the jacket. So all these cables here are 105 degrees Celsius cables, 221 degrees Fahrenheit. And based on how hot that jacket or how much heat that jacket can take, that dictates how much amperage can go through that line. And so they all have a max like this. Let's see. So we have 6 gauge here. That's 115 amps max. We've got 1/0 or 0 gauge here. That's 285 amps max. So they all have an upper ceiling, and you want the fuse to be at or below or around that rating. And what I'll see is people will, let's say the fuse blows for some reason, people will increase the amperage of the fuse. Let's say the fuse here at the beginning of this line they'll go ahead and bump up the fuse rating, not thinking that it's related at all to the cable that it's protecting. So these fuses protect these cables. If, let's say, there's a short circuit in this device, these cables are feeding that device from here. We want these fuses to blow before these cables melt or catch on fire or ignite, right? So you want to increase the fuse rating as you increase the amperage rating of the cable. They're going to go up and down as a team, and they're both going to work as a team to supply power to that load, a load like this multiplex inverter charger. So they're going to go up and down as a team. The cable rating can be above the fuse rating if you want. It's a little bit of a waste, but you can have a cable that carries, say, 200 amps and a fuse that is 100 amps. That is okay. You just don't want to do the reverse where the fuse allows 200 amps through that line and the cable can only carry 100 amps, because basically if there's an issue here, the cable's going to heat up and ignite, and that fuse is going to continue feeding power down that line. And so that's why every line is going to have a fuse or a breaker. It's overcurrent protection to prevent fires. So you definitely want to see your cables and fuses as a team and rate them approximately the same or related to each other. Moving on, we have stainless steel washers between conductors. So again, this is something I've seen. This happens a lot in a Lynx distributor like this. You're going to find stainless steel washers in there that come with it from the factory. And just to make it super simple, the stainless steel washers are only there to smash things together. I want to make it just super simple. They look the same color as the tin plated copper. And so people end up putting them in between the fuse and the cable, and they do not go there. And what happens is the stainless steel is such a poor conductor that it is going to get super hot, because you will cram a bunch of amperage through it and it's just going to get super hot, and it may blow your fuses early. It's going to get your fuses overheated. And this is something that just people get all these stainless steel washers, they take it apart, especially with little fuse blocks like this. And they put that fuse in between, or put the washer in between the fuse and the cable. So please don't do that. It will get very hot. Another one that I've seen, one of my students had a DC to DC charger catch on fire. He basically didn't give it enough room to breathe. And so with these devices, like this one will tell you 10 centimeters on all sides. You want to go ahead and read the manual and respect those clearances, because anything that converts voltage up or down is going to have waste heat. It's going to produce heat. So this one is going to go 120 volt down to 12. It's also going to go from 12 up to 120 volts. So whether it's in the charger mode or inverter mode, it's producing heat at all times. And so you want to give this thing some room to breathe. But all of these have some space provision in the manual. And in this particular case, one of my students moved it too close to a wall, and it caught the wall on fire as well as the device. And if he hadn't put out that fire, it could have burned down his entire van. So definitely a safety hazard there. And a lot of these machines have a temperature probe where they'll throttle back the current running through them, or they'll shut down if they get too hot. But we don't necessarily want to count on that. And if you do suffocate these by not giving them enough clearance, then they may work properly and they'll just throttle down the amount of current running through them. And so you'll get less power out of them than they're rated for. So in order for optimal performance, you want to go ahead and give them that space all around. The next one is number 6, no fire extinguisher. So I had to throw this in there. This is an easy one that a lot of us may not think of, but I would definitely, and really in any vehicle, because they all have the potential to catch on fire. The engine, or if you're putting a system like this in a van or RV, you've got a lot of things that could catch on fire. So definitely have a fire extinguisher, maybe an ABC or one that's specifically for automotive or marine applications, and make sure that it's up to date and is pressurized. And if it's not, go ahead and replace it. But I would definitely keep one of those on board. I thought I would throw it in there. Maybe that's an obvious one, but I know a lot of people stand to the side and watch their boat or their vehicle burn because we don't all have fire extinguishers. Number 7 is wrong fuse type or no fuse at the batteries. Again, a consulting call the other day I had, the guy had purchased a van from someone else. There was no battery fuse. So I don't know who built that system, but I have evidence that at least one person did not put a fuse on the batteries. So you definitely want to have a fuse at the batteries, ideally within 7 inches. That goes by the ABYC standards, the American Boat and Yacht Council. So within 7 inches, if you use a terminal fuse like I have here, it goes right on the battery terminal. So the job is done and you can move on to the rest of your system. You can also use, and that's called an MRBF, marine rated battery fuse is one approved type. There are 2 other approved types by the ABYC. These are a little bit, say, stronger fuses. They're going to have a higher amperage interrupt rating than some of the cheaper fuses like these. So MRBF is one, ANL is the second one, or Class T is the third. So any of those qualify to use on your battery bank, and you definitely want to have a battery fuse. So I'll leave it at that. Number 8 is going to be oversized lug terminals that are too big for the stud that they're going on. So that would be like these guys are going on an 8mm stud, and they have a hole that is 8mm. And basically, if you run out of these lug terminals and you may have a few of a different size left over, the hole in the lug terminal may be too big for the bolt that it's going on, and there can be some issues with that. Number 1 is reduced surface area. So surface area is a game we're always playing with these conductors. We have to have surface to surface contact. And when you reduce that contact, you're forcing more current to go through a smaller area. And so when you have a lug terminal with an oversized hole for the bolt, you're reducing the surface area potentially that can go from that lug terminal into that other conductor. Let's say if you have a bus bar like this. So you're reducing the surface area contact. Also, if it gets off center, the nut that tightens down on it can tighten down on one side of the lug terminal more than the other, causes an imbalance, and it may lead to that loosening over time. Whereas if that lug terminal fits the bolt perfectly, it's going to be less likely to vibrate loose and move around, and you're just going to have a more secure connection. And secure connections that are not loose or don't vibrate loose are the name of the game for these mobile power systems, because we have a lot of vibration going on. Number 9 is improperly angled lug terminals. And so if you stack lug terminals like we have here, we have one coming from the bottom and one coming from the side, you're supposed to angle those 90 degrees from each other. You can do up to 4 by ABYC standards, so they would go in a cross configuration. But what happens sometimes is you'll put one lug terminal and you'll stack the next one on top of it, and you'll rotate them where they are right on top of each other. And what happens is the one on top basically gets lifted up. And again, that surface area contact is reduced because it's not sitting all the way down on the other lug terminal. There's a gap in there, and basically you're cramming a lot of current through a small surface area. It's going to get hot. And so that's why by the ABYC standards, American Boat and Yacht Council, they're going to tell you to keep them at 90 degrees from each other, so they all have plenty of real estate to sit down properly and get that full surface area contact and good conductivity. So that is number 9. Number 10 is not having a ground neutral bond. So this is dealing with high voltage now with our inverter charger. So basically, I'm going to try to explain this simply, but you're going to send power out 120 volts hot in our case on the black wire. And if there is a ground fault and that black wire electrifies, let's say, the case of a toaster, the case of that toaster is grounded and it's going to travel back on the ground wire to the source. So that could be this inverter charger. Well, basically, If the ground is bonded to the neutral inside the source, then the source is going to, from its perspective, send the power out on the hot, and it's going to come back on the neutral. And basically it's going to overload and it's going to trip the breaker and shut down this dangerous ground fault. If you do not have a ground neutral bond inside here, it's just going to let that dangerous ground fault situation persist until a human walks along, touches the toaster, and it can conduct through the human and electrocute them. And so that's why in a building, you're always going to have that ground neutral bond in your main power panel. But with an inverter like this occasionally becomes the source of your electricity when it's running off batteries. And so you want the ground neutral bond to occur inside here as well. So you want to make sure that if you have a regular inverter, that it has a ground neutral bond internally. If you have an inverter charger like this, it's going to have a ground relay that is going to create that bond when it's running on batteries. But when you plug in the power grid and run the power grid through here, this is no longer the source of the power. It's just a pass-through point. And in that case, it's going to open up that ground relay, break the ground neutral bond. And you don't want that bond in two locations, or else you're going to have electrical current flowing down your ground wire between here and the shore power pedestal outside your vehicle or boat. And so that is illegal and dangerous. And so you need a ground relay with an inverter charger that opens and closes appropriately. You want to activate that in the settings. And if you have an inverter, you just want that permanent ground neutral bond. So hopefully that makes sense, but basically you're preventing yourself from being electrocuted during a ground fault. And the other way that you could prevent this is a GFCI breaker. You can have the breaker at your breaker box and it will protect that entire line. And that is U.S. electrical code now for kitchens and bathrooms and things like that. But you can put those on all of your lines. But the traditional way to do it is just to have the ground neutral bond at your main power panel. So those are electrical hazards, the top 10. Hopefully that was useful. And hopefully some of those you already had covered and you already knew not to do that. But these are things that I've seen, so I hope that was useful and helps you build better power systems. So thanks for watching. Be sure to grab your copy of the Ultimate Van Power Cheat Sheet. Just click the link below or go to rosslukman.com/vanpower. Thanks for watching, and I'll see you in the next video.